Hi, everybody. My second crack at this. Unfortunately, my computer messed up on me right at the end, so I am excited to be here again. More word questions. There's actually a wide variety of situations that you can apply a quadratic to. What I've done is I've selected some questions, styles of questions that we did yesterday, and we're going to do different styles of questions today. Hopefully, at the end of this, you'll be able to apply it in pretty much any situation. Um, but I figured at least this way you could get comfortable with a couple of situations and expand from there as well your academic career requires. So, the volunteers at a food bank are arranging a concert to raise money. The relation blah 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 models the profit in P in dollars for the concert where N number of tickets is sold. So determine the number of tickets that they must sell in order to maximize profit. Well, as soon as you're looking at maximizing, it means we're looking at completing the square. And for some reason, I don't like writing all the zeros in this. Minus. So once we've got this, max profit is $36,100. Okay, calculate the number of tickets. Well, in this case, it's already calculated. So when 290 tickets are sold, you get a max profit of $36,100. We've already done the math above. Don't need to do it again. All right. So here we have a second scenario. Maggie can kick a football 34 meters in the horizontal, and the ball reaches a maximum height of 16 meters. Write an equation to model the situation. So you could actually model this either way. You could do vertex form, you could do factored form, um, and both should give you the same answer. For no apparent reason, I'm going to use vertex form. So the max height was out and out given to us. However, properties of a vertex right? We know that the vertex at the max height occurs right in the middle, so it means that our vertex happens at a horizontal distance of 17 with the max height of 16. Okay, now we're indirectly given two other points. We know that it starts on the ground, or at least we're making that assumption. We're also making the assumption that it returns to the ground. So I could use either point. I choose to use 0, 0, because you don't get much easier than zeros. Now, before we go any farther, h equals height in meters, and d equals horizontal distance. Now, it really should be horizontal distance from where it was kicked. while I might get picky in a lot of things, I'm not that precise. And let's start solving for A. And we have an equation. Part B, this is just the same equation written out. To score a field goal, the ball has to pass through vertical poles and over a horizontal bar, which is 3.3 meters above the ground. How far must Maggie be standing so that she's got a chance of scoring a field goal? In other words, how long? In other words, when is the ball over 3.3 meters? So if we find this intercept and we find this intercept, we know that anywhere in between will give us the maximum difference, will give us the where it hits 3.3. Really? So, right? So this part here is no good. And this is the farthest here. It's actually cheating a little bit because if it's exactly 3.3, then it should be hitting the poles. But we're going to give it a grain of salt. We're just going to accept it. So in this case, we're not looking for a maximum or a minimum, so we got to solve for D. So we have to put this into standard form in order to make this work. Unfortunately, this is a long solution. So I'm going to cut a few corners here to try and speed things along. We'll get rid of that. Hold on a second. Whoa, whoa, whoa. Okay, in case you're wondering what the holdup is, part of it was because I'm looking at my solution going, why I don't understand why I've got a different answer on there. And then I realized I haven't done anything with my 3.3, so it's got to get substituted in. And then we move it over, so that 16, where'd it go, becomes 12.7. All right. Come on. No. Oh, my computer's starting to glitch again. Hopefully it holds out long enough that I can finish off this recording, because I have other things to do. Now, at this point, we're back into yesterday's lesson, albeit messy. So for those of you who are comfortable with the quadratic roots equation and want to just get started on your homework, here's the assignment. And for those of you who want to see how this cliffhanger ends, well, I'll finish it off right now. Neat. It does not. There's something. Oh, there we go. Now remember, this first number, the 1.8, where'd my drawing go, corresponds to this value here. And while it is accurate, oh, actually, I thought it said the maximum. Okay. So, therefore, all right. Yay, my computer held together long enough for me to finish this. I'm out of here. Go do some math homework. As always, give me a shout if you have any questions or concerns. Cheers.